Hi everybody, my name is Bhavishya and in this lecture we'll see the lab of our ASPR, how it works. So here we have this topology where in this autonomous system OSPF is running as a routing algorithm. Here we have another autonomous system where RIP is working as routing protocol, right? And we have connected R6 with R7 where R6 will behave as ASBR, Autonomous Border Router. Right, but for it to work we have to enable OSPF to work as an ASPF. How we do it we'll see in a bit, but before that let's understand the scenario. What is happening is in between R6 and R7 RIP is working, right? And here also RIP is working, and here throughout this topology OSPF is working, but there is no interconnection between them as we have not allowed OSPF to redirect all the packets from here to here, right? And for that, what we will do is we will redistribute all the packets from here to this OSPF. And for that, we'll use the command redistribute rip subnets, right? After that, what will happen? As R6 will start working as ASPR in its router LSA, it will start showing that okay, me R6, I am ASPR. And when R3 will see that in its router LSA, in R6 router LSA, it will generate a type 4 LSA, which is ASBR summary LSA, and it will propagate it to R5 and R2 with its own router ID. As R2 will receive it and as R2 will propagate it further in area 1, it will propagate that by changing its router ID to what was initially it was, right? And not only this, what extra will happen is as all the RIP networks, all the networks that we have learned through RIP and that then we redistributed it with the help of OSPF, everyone in this topology will going to receive that. And when we'll check in R1, we can see there it will tell us that OE2 that it has learned with the help of OSPF external type 2, right? As initially we saw that OSPF IO like IA, that inter area thing that we saw, right? Here it will we will see that it is external type 2, OSPF external type 2, right? So yeah, after that what we'll do is we'll try to ping from R1 to PC1, and for that what we'll do we'll see that. So let's begin. So I've already configured the interfaces. Now we'll check how R6 is behaving before becoming ASBR. For that, we'll go to R6, we'll say show IP OSPF database. As you can see in the database, yeah, it looks normal, right? But there is a catch that if we look at R6 router LSA, there it gives us the information that if the bit for ASBR is set to true or not. For that, command is show IP OSPF database. Then we want to see which type of LSA, router LSA, right? Router LSA, then ADV router. What is the ADV router? 6.6.6.6, right? Here as we can see is giving us no information if it's ASBR or APR. Okay, now moving forward, we'll see it in a bit when we redistribute it. Now let us go and configure a RIP for R6 and R7. Let me pause it here. In R6, we'll give the network 67.0.0.0, right? And in R7, similarly. In R7, we will give two networks as we have two interfaces connected to two different networks. First is 67.0.0.0. The another network is 10.0.0.0, right? And this is pure RIP. No other thing is working right now. Pure RIP autonomous system right now. So to validate that, we'll go and check. We'll say show IP route. And here we can see that through RIP it has learned about the 10 network. Right, and also 67 is directly connected, right? So both of them are connected, but after configuring it with OSPF, it will tell us a different thing, right? And still, if I'll go and check the same thing what you have checked, it'll give us the same thing. But now let's do the final step, which is redistribution of OSPF. To RIP for that, config terminal router OSPF, that's host 20. Now the command is redistribution. Okay. Oh, redistribute RIP subnets. Wait, yes. Before that, after this, what will happen? R6 will become ASBR, and then it will propagate. It will propagate the type 5 LSA, right? Which is external LSA. And as it will become ASBR, we can see that in its router LSA that it has set itself to ASBR. R3 will catch that and will generate as it is a area border router, right? So it will generate type 4 LSA. So redistribute subnets. After that, we'll go and check show IP route. Oh, not this command. Yes, this one. Here, as you can see, after I use this command, show IP OSPF database router LSA type, advertise router R6 router ID tells me that AS boundary router, right? ASP, right? Yes, and also in the database, if you'll check show IP OSPF database, so it is generating a new LSA, which is my external LSA type 5 for network 10 and 65, right? Yes, and also if I'll go to R1, I'll check is it so that you can see the screen. Go to R1 and check show IP OSPF database. Yes, we have the type 5 LSA here, right? And also we have type 4 LSA too. ASBR summary LSA, right? And for R6, and who's generating it? 2.2.2. But if you'll go and check in R3, show IP OSPF database. And here if you see in R3, the type 4 LSA is generated by R3. So when R6 become the ASBR and R3 get to know that R3 generated type 4 LSA by its own router ID, sent it to R2, and as router 2 received it, before sending it to the corresponding area, which is area 1, it changed its router ID with its own and propagated it. So you can see the proof here, right? Yeah. Now the big thing, which is show IP route. As you can see here, OE2, and it learned with about 10 network, and also about the 67 network. What is this OE2? OE2 is OSPF external type 2 LSA. It's an advanced topic. We'll learn it someday. But yeah, this is OSPF external type 2, right? And we have the information about 67 and about 10 network. Now, if I want to ping from R1 to PC1, will it happen? No, it will not. Why? If I if I want to ping from R1 to R6, it will happen because the path is there. If I want to ping from PC1, router 1 to PC1, it will happen from here to here only, but the returning path is not there because from R1, about if you'll check the 10 network, what is the next stop? This is the next stop. For 10 network, what is the next stop? This is the next stop. From R3, what is the next stop? For 10 network, this is the next stop. For 10 network, what is the next stop? This is the next stop, 67.0.0.7. Now what is the next stop? It is directly connected, right? But when it wants, but when the ICMP request wants to go back, it has reached here, but when it wants to go back, okay, this is the this is the default gateway. But after that, we have no place, right? So there are multiple techniques that we can use, but we can even redirect from RIP to OSPF as we have did before, that OSPF to RIP. We can also redirect from that. But the easiest path is that to provide the default gateway. Default gateway is already there. The best part is to provide default route. So let me do that. This is the default route that I've given, as you can see here too, because it has only information about 67 and 10. Now if I'll go in 2, it will happen. As you can see, it works. And also for network, also for this, it also works. Let's check. Here as you can see, it works right for this network. So I hope you enjoyed. See you in the next one.